All right, welcome everybody. Thanks for being. I hope the photo-induced coma is settling with you by now. So I'm here today to talk about what we've built for our CICD pipeline at VMware. So VMware is pretty decently sized company, has a lot of engineers working, and it's a really old-fashioned software development shop, if you ask me. But we had a chance to work on more forward-looking things since we created this new cloud-native apps business unit a few years back. And I'm going to show you what we built, over the past 18 months to actually, test and ship products in this new view. So, very quick introduction. My name is Fabio, as you can see. I'm not the Fabio with the long blonde hair you probably remember from the late 90s. I wish I was, actually, but I'm not. You can find me on Twitter. That's the only social network I use, mostly. So if you want to, talk about pretty much anything that has to do with IT, just, ping me there. I'm usually very active, except for this week. Again, I work at VMware. I'm actually the original engineer in the Cloud Native Apps group. When we formed 2 years ago, we were 6 people total, including the GM of the view. We're now at about 85 people, so we've grown up a lot, and most of them are engineers, so it's a fun place to work at. We're kind of like a startup inside VMware. That's how we like to call ourselves. Before going back to development, I used to be an infrastructure architect, and I did that for a good chunk of the past 10 years. I still entertain working on infrastructure, and that's exactly why I'm here presenting this. So, especially when it comes to distributed systems, when it comes to microservices deployment, it's still something that really keeps me interested. I'm also, I used to at least, be a very active open source contributor. So before starting working on Project Cello, that's actually how I spent 100% of my time at VMware. For a good chunk of 2015, I basically contributed code to pretty much every DevOps tool out there, especially around VMware compatibility. So if you're running Docker machine or Vagrant against VMware platforms, there's a pretty good chance that you're using code that I wrote. So now I'm working 100% on Project Cello, but still, given that we rely on many open source projects, I still contribute a lot back. And so many of the engineers working now on the same project as I do are kind of getting into the understanding that, consuming open source does not necessarily mean we get code for free, we get products for free. It actually means that you want to enhance those products, contribute back, and give back and make those products better, because everybody can reap those benefits, not just us. There's some goodies if you like scripts and stuff for VMware, again, mostly around Vagrant and Docker and Terraform and so on. You can find them on my GitHub page. It's right there. So Cello, what's Cello? So Cello hasn't been released yet, first of all. It's an early stage project. It started about 12 months ago. I will say that about this time last year. Again, it's the project that is totally incubated inside the Cloud Native Apps view, so it's an original idea we had back then. The goal of Cello is to become a platform for self-operating stateful clusters. It will obviously manage stateless clusters too, but stateful clusters are much harder to manage, obviously, because of the state part. So think of it as a supervisor for your applications. And the platform we're creating will allow you to run and manage the self-operating, self-managed application across multiple clouds. So right now, we're currently running kind of a private beta with some selected customers of VMware. But we will send out the first batch of invitations early next year or so. I will say about Q1 next year. So if this is interesting for you, just head up to the website that is listed there, preview.celloproject.io, and sign up for an invitation. We're going to send them out. So let's get a quick introduction on what is inside the box of Cello. So Cello has one major core component, which is the SaaS service. Okay, so the SaaS service is comprised of many different microservices. Right now, we're about 10 microservices, 10 different microservices, but it's growing really fast because, when we go forward, when we add new features, new things, they break out into many different microservices. And each one of them is developed by a different team or a different engineer. So it's all decoupled. It's not just a monolithic application we create and deploy at the same time. It's just literally small teams of maybe 1, 2, 3, 4 engineers tops that contribute into a single piece of the code, single microservice, and deploy that independently of one another. So all the microservices you see, and this is like a kind of a neat representation of them in boxes, they have an API contract. And the API contract of these services is defined as a Swagger spec. I'm going to talk a little more about Swagger going forward. So Swagger gives us the ability to create a contract, which is literally just a YAML file that specifies what the API of the application looks like. And we actually use the same definition to create documentation too. So we have this nice YAML file that depicts all the API endpoints, all the API actions happening for that specific microservice. And with that, we create documentation. So it's a live documentation thing going on. So I was saying that we have the small teams that write the microservice. We tend not to specialize engineers too much. So what we do is we assign people to a specific microservice. They write the code, they work on it, they optimize the microservice for like 1, 2 milestones, which are usually about 2 sprints each. So we're talking about 2, 4 weeks, depending on the size of the project, and then we rotate them to another microservice. So everybody knows pretty much how the whole system works, not just their own little island, their own little microservice. And this is all about the core. We also have obviously 2 major user-facing clients for Cello. One of them is the CLI, and the other one is the website. And both are released through the same pipeline the services are going through. It's just a slightly smaller one. So this is the shopping list of the tools we're using. We're mostly using Go, as you can see. So Golang is our language of choice. Pretty much all the code base is written in Go, except for the web front end, which is written in, I think it's AngularJS. I'm not sure because I'm not a front end guy. So we have a few engineers that are specialized in UI, UX, and they work in JavaScript. They're using Angular. So pretty much all the tools that we use, except for Spinnaker, are actually built with Go. So I would say that not just the code base, but also everything else that revolves around Cello, revolves around all the tools that we use to build and operate Cello are written in Go. So whenever there's a problem, we know that we have all of engineers that are able to look into the code easily and fix it. Well, not easily necessarily to fix the problem, but easily they don't have to, switch languages. We have a few people that are proficient in many languages, but not all of them. I would say that most of the engineers we work with are, given that they work most of their day on a single language, they mostly like to use a single language. So we said Swagger. So Swagger has several implementations. We're using an implementation of Swagger written in Go, which was actually a project built by one of the engineers working on Cello. He actually created the project before joining VMware. It's actually very well done. It's very fast. And it's not only leveraged by Cello, it's actually leveraged by pretty much all the projects, all the products inside VMware that are using Go. So there's a bunch of other projects like VIC, which is vSphere Integrated Containers, which is trying to bring Docker and VMs together basically on vSphere, and that is using Go as well, and it's using Go Swagger at the same time. Our source code management is obviously GitHub. Pretty much everything that the Cloud Native Apps BU does is stored on GitHub. We have a few organizations where we incubate projects and graduate them, but that's where we keep them. Docker. How many people use Docker? All right. All right, well, I thought there were more people. Okay, cool. So Docker is, I would say, not the gold standard of runtimes, but the gold standard of packaging format in the container world. So as far as I'm concerned, packaging format for Docker is something that they got really right. And we do use that extensively. So pretty much every artifact we create, except for the CLI, obviously, is actually packaged in a Go container. Actually, we do have a container that contains the CLI as well, but that's another way we distribute that. So those images have to end up somewhere. So we have a private Docker registry called Harbor, which is actually a VMware project. So if you go to github.com/VMware/Harbor, you can find this private Docker registry, which is actually very well done. It was created about 12 months ago as well. It's currently one of the most popular projects we have on GitHub. Very well done, has a UI, has a web UI you can use. It connects to LDAP, it has image replication features. It's very well done. It's all open source, so if you want, go check it out. Also, both the CICD pipeline, so the whole service that runs the CICD pipeline, as well as the actual service, runs on Kubernetes. We run Kubernetes on a vast array of platforms, from vSphere to Photon Platform to AWS to Google Cloud Engine, pretty much everywhere we can. But that is the layer we use to manage the application. And then we use Drone. So Drone is it's an interesting choice. I'm going to talk about Drone a lot during the presentation, so I'm not going to focus on that right now. Drone is a CI system written in Go, which is, it's an interesting piece of software. It's not as popular as Jenkins or Travis CI or the various hosted CI system there that you can see on the web, but it's actually very well done. So I'm going to talk about that later. And then we recently added Spinnaker, which is a project by Netflix and a few other companies that is actually helping you with the continuous delivery part of your pipeline. So it takes your Docker artifact, your Docker image, and takes care of deploying that for you on the cluster of your choice. And also, we obviously use Slack as our notification sync. So pretty much everything ends up in Slack, because that's where everybody hangs around. Also, I'm working remotely, so everybody else is in Palo Alto. I work from home in Italy, so it's the only way I have to keep track of what's going on. So when we started the service, started building the service, we wanted to create some sort of pillars to build our quality ID on top of. So we came up with this three, which is all the code that reaches the master branch of any service must be deployable. So you never, ever, ever break master. If you break master, something is wrong with the process that got that code into master. So we have to fix the process first. Hasn't happened yet, thankfully, but that's the way we approach it. All the manual intervention that happens in the pipeline must be strictly related to approval. So some human has to look at that and say, okay, this is good, I approve it. This is bad, I reject it. That's it. No manual building, no manual provisioning, no manual deployment, no manual actions at all except for human decisions. And also, whoever wrote the code is responsible for running in production. So everyone is on call. Everyone has not a pager now, but has pager duty, okay? So every area engineer, including the engineering manager, has it. So why Docker? Docker is obviously a choice for many people right now. Again, it's so easy to get started. The learning curve is practically non-existent. There's a well-done packaging format, which is the one they're using. And if they're done correctly, Docker images can be very tiny. That's what we try to do. So our prod images, all of them are smaller than 50 megs in size. That's also a feature of Go, because Go builds static binaries that are usually huge, but can be packed very efficiently. I'm gonna show you how we do that. And also there's a large ecosystem to tap into, obviously. So how do you package Golang microservices into Docker container by keeping them small? You just steadily compile them. You compress the resulting binary with UPX, which is a very old favorite project of mine. It's very old, actually, but works very good. And you use tinyframe image that only contains root certificates and MIME type lists. We don't have to build an operating system into the Docker image we ship, because everything is inside the Golang compiled binary. Everything is inside it. So there's no need to do anything else. There's only the actual binary inside and HTTPS certificate, because that, whenever you do an HTTPS connection, you have to qualify that connection against the root certificate. So we end up with very small, very tiny, and nimble Docker images that can get moved around very easily. And also they don't cost a fortune when you host them on S3 or Google Storage. Because you end up having lots and lots of those images inside the registry. So why drone? This is my favorite part. So drone uses Docker as a foundation for every CI job it's running. So this is a very opinionated way of doing things, and we had to work around issues in the past because of this. But once you wrap your brain around it, it's an extremely efficient pattern. The code base for drone is very lean. It's written in Go, and this thing helped enormously when we had to fix or introduce new things into drone. Again, it's very lean, it's very easy to add new things. It's very easy to add new plugins, because plugins are Docker images themselves. So drone runs as a server, and then every plugin you have is another Docker container, completely separated, just having an API to talk to that. Also, one thing that pretty much, I would say it's unique to drone. I'm not sure if it's the only one, but it's pretty unique, is the fact that given it's relying only on Docker as the engine, you can actually have, there's a drone CLI utility you can run on your computer, and given a Docker engine installed there or even remote, you can run the same CI job you're running on your infrastructure locally in your machine. And this helps enormously when you have developers that are running the dev test typical life cycle, where you have your code running it, and then you want to test it. So you can either test it locally with your own dependencies, your own things, or you can run the actual CI job on your machine and make sure you're not making a mistake before you sending a PR out. And also, the job configuration is stored inside the Git repo. So once you have the Git repo, you have everything you need. There's no jobs stored somewhere in a database or in a file inside a CI system that you forget about, and maybe somebody deletes them and you lost it. This is a typical definition of a drone job. This is actually part of a larger specification, but even just this will work. This is something from a catalog service for us, which is basically telling us we need an image, which is Golang, which is the Golang official image for version 1.7. So we're compiling, we're running all the steps from, you can see from the commands. We're running a bunch of gets, we run the makefile, target, we generate the code from Swagger, and then we test everything. Also, Swagger is very interesting because from the API spec you create, you can generate the actual code. So you create the client code and the server code for your application. So you don't have to maintain that, in a manual way. You just generate the code and you're done with it. It's very easy. So everything you run here has a return code. If the return code is 0, job has succeeded. Anything that is not 0 is failure. And this is our mantra. So always be testing. Since we started, everything had to have tests. Unit testing, integration testing, all of them. And we wanted to make sure that every developer understood very well that quality is their job. It's not the job of the quality engineer. There's no such thing as a quality engineer. There may be somebody who takes care of the infrastructure of the quality system, but it's not his job to make sure that the quality of the product is high. It's the developer duty to make sure that the quality of whatever he's writing is top-notch. That's why we keep this as a dashboard in the office on the engineering manager. So everybody sees what happens. And that creates also, some sort of, not necessarily competition, but, you want to be the top of the leaderboard for, and Jake is obviously one of the top leaders here. So this is a typical, what happens typically, in the development life cycle for us. So what happens is we have a PR that starts, somebody submits a fix that, most of the time refers to a bug that was filed. We have 2 developers review the code, and at the very bottom you see there's 2 things happening, which are drone actually running 2 jobs. Here we're running end-to-end test and unit testing. We require both of them to pass and having 2 reviewers to review the code before we can actually merge that. So we're pretty sure that everything that happens is okay. And this is, so we're going to start with a few of these diagrams that show the pipeline. So this pipeline is very typical for us because we start from GitHub, somebody sends a pull request. During the pull request, there are unit and acceptance tests being run, as you can see from the previous slide. And drone runs them. So drone runs them continuously. When they're green, we merge them. When we merge them, at some point we decide to tag a release. So somebody manually tag a release in Git, and that triggers the whole end-to-end testing. So the more comprehensive test that they can run for multiple hours. In this case, we're looking at the CLI. So this is how the CLI is being packaged. So the CLI, when something gets merged on master and tagged, what happens is that drone runs the whole end-to-end test, which is deploying application on actual clouds, managing them, and testing them for various conditions, right? And this is a job that can run for like 3-4 hours easily because it tests multiple clouds and so on. So whenever that is done, which is only run every time we make a new release, if that passes, then drone will package that compilation of code, that binary, into a Docker image, into an RPM package, into a DMG for macOS. And this is what happens every time we do a release for a user-facing tool for Cello. So this happens for the CLI, and this happens for the website as well. For the SS component, it's pretty much the same thing, except the acceptance test, the whole acceptance test, is run, again, only on tag. So we only do unit testing for SS components. SS components, because, again, SS components require creating a new sandbox with all the microservices in it, because we want to replicate the whole environment again. So the acceptance test will run only when we tag a new release. And again, the same thing happens. The only difference is that we only have a Docker container resulting in the end, which is one of the tiny Docker containers I showed you before. When that happens, we have a bucket where we have all the Docker containers with all the services tagged. So what happens is that we move into the continuous delivery of that. And we're now using Spinnaker. So we used to have like Ansible playbooks and bash scripts attached to drone before. So what happens, instead of drone just pushing the Docker image to a Docker registry, we will have various Ansible playbooks being run after that to talk to our systems and start deploying the new code. But that wasn't flexible enough. I mean, it was working okay, but it wasn't what we wanted because it wasn't flexible at all. So we looked into the various options. We found out Spinnaker, which is very, it's very new, but it seems to be very promising. So it gives us a few things that are very, something that we were very looking forward to, which is approval gates. Again, a human that has to approve something. Okay, we're not 100% automated yet because we still have to have security to approve a new deployment. Until we actually automate that too, which is on the roadmap, but we don't have that yet. So we have to have a human to actually approve that and say, hey, this is secure, right? So it's a human that runs a script, by the way, but yeah, regardless. It's nicely integrated with Kubernetes, which is our platform of choice. it's not tightly coupled with the CI system because the only thing that basically keeps the two together is having a Docker registry in common, and has so many different triggers. We use the Docker registry now, but we have ideas for using like GitHub triggers and many others in the future. So it's not yet used by all the services. We have a few of them on Spinnaker now, but it will be adopted as the main tool for hopefully by the end of January. And this is what the full CI/CD pipeline looks like. So it's the same thing on the left-hand side, but when we have the artifacts stored inside Docker, inside the Docker registry, that triggers Spinnaker and triggers a set of actions inside a pipeline. So the pipeline goes like this. It starts by immediately deploying to staging. So we deploy the staging, which is in the same environment. It's just stacked differently inside Kubernetes. And it's being routed by the application. So we have a router at the very top of the Cello SaaS service that tells people if they have to access the staging environment or not, or the prod environment. So we have people looking into that. Mostly, security people reviewing that, all the sort of kind of release management things we have to do at VMware, okay, that are not automated yet. When somebody says, okay, this is good, this can go to production, then they click on a button that says approve. And approve will trigger the deploy to production. So same thing, but we deploy to the production hosts, basically, in the same cluster. And that is kind of like a double deployment. So we deploy two versions at the same time of the service. And then we have some sort of, this double deployment goes on for a few days, usually. When there's somebody saying, okay, everything is good, everything is fine, we can remove the old version, which is another click that says, okay, we approve that this version is working correctly, remove the old one, which is the last step of the pipeline. These are two manual gates that we are looking at removing as soon as possible, but we haven't got there yet. So lessons learned from all this. Writing integration tests is extremely hard for people, especially for developers. So if you're working in operations, you know how to approach black box binary. So you have a binary which is for you a black box. You put some input in and you expect some output out. This is something that a developer doesn't really have in mind. Okay, so it's very hard for them. It's very easy for them to write unit testing, but it's so hard for them to write real black box type of tests. So when I started, I was the only one writing them. And now we have pretty much all the team writing, except for the very junior people writing integration tests. But getting there has been a long process, very long, and it's still difficult to get them through. Running CI inside Docker containers has a very steep learning curve, but pays off in the long run. So now once we ironed out all the problems we had in the past, we're in a place where we know pretty much every time we have new things coming on, we know how to deal with that in the CI. Having the clear and codified API contract makes everything much, much easier. So Swagger is giving a lot of help in this. Last one is going from 99% automation to 100% for a CICD pipeline takes a long, long, long time. Because the things that you don't automate at the very beginning are the ones that takes most of the time for you. And when you get there, it takes so long to get from almost done to done. And I'm talking mostly about our release management process, which is, I guess, close to pretty much any large development shop out there. We have a security testing and review. We have open source and third-party code review. If you ever integrate with third-party code, you have to review all the packages you have in it. There's a lot of legal involvement too. There's a lot of things to do. Also, export control, which is something I've never heard of before I actually started working at VMware, but it's a thing, and you have to deal with that. We have a bunch of things we have to improve here. So we want to partially automate code reviews. Most of the time, code review is a developer that has to stop working on the job to look for like formatting issues or very easy to spot errors. So there are services out there, SaaS services that help you automate those type of analysis. So there's a robot that will connect to GitHub, look at the code, and basically run the linting for you and create comments, creates requests for review inside GitHub for you instead of implying a human resource to do that. Obviously, continuously developing the Spinnaker pipeline. So we want to have automated performance test, which is the next thing we're going to work on. So we want to have load testing happening before we actually release. Going from 99% to 100%, which is basically requiring to automate the last steps right there. And we have open source projects available today. So I know that VMware doesn't have a good rep on open source, and I know that. I was one of the ones trying to change this, still trying to change this. But we have a lot of open source projects out there you can download today. Most of them are coming from IBU, but doesn't matter. It comes from VMware anyway. So vmware.github.io, there's a bunch of them, including Harbor, which is very interesting. Also, if you're running a vSphere in any shape or form, go check out vSphere integrated containers. And I'm done. Thank you. Do we have like 10 minutes for questions? Okay. Any questions?
Could you use the mic in the middle of the room?
Yeah. You guys far away.
Hi, my name is Marcin Lusterski. I'm from the New York Times. We are deploying to GKE. Mm-hmm. And we have our own drone plugin to deploy containers to it. Uh-huh. So I was wondering how you solve this problem with Spinnaker. Is that you interact with Spinnaker from your drone directly, or is it a separate system that shares, access to the registry?
So we used to use that plugin too. Okay. For a while. It didn't suit our needs. So with Spinnaker, we're actually removing that altogether. So drone never gets in contact with Kubernetes at all. The only thing that drone does is it builds the Docker container and push the Docker container into a registry. That's it. Once you populate the registry, then Spinnaker gets triggered by that action. Okay. So registry tells Spinnaker, hey, there's a new container here. You want to do something about it? And Spinnaker will take the container and start the pipeline. So drone never gets in contact anymore for pretty much all the services.
Okay, awesome. And the second question, when you're running those long-running jobs, testing jobs with a drone, we ran to an issue where we were just running out of resources because it was creating so many containers. Did you solve that somehow?
Well, let's say that the way we solved it is very easy. So we do use GKE to run drone, actually, to run the integration test especially. So what we do is we basically we use a daemon set for agents. So whenever whenever we see that the jobs are taking too long to complete, we just expand the clusters. Given that the daemon set will expand the number of agents for you, the agents will connect back to the server. We basically, with a 15 minutes worth of working, which is just literally creating the gcloud command line, we get more resources for that. Okay. And we actually have a extensive monitoring infrastructure going on in the back using Prometheus, which monitors those thresholds. It's not automated yet. I wish it could be, but it's not yet.
Okay. Yeah, we're still running drone on AWS, and we're trying to deploy it. So
we used to run drone on physical servers before, actually. Well, physical server. We used to run that on ESX, but we decided to move that to GKE just because we could expand, especially if we have, time of year where we have, we need more resources. So we just scale up, and then we scale down when we need to.
Awesome.
And that will take care of it.
Thanks.
Hi, my name is Jimmy Graham. I work at NIST, and I just want to know if you can provide some more information about your security review process. Is it something that's automated? Is it something that you have to wait for your security team to run separate tools on?
Yes.
Does it encompass the entire stack, or is it simply code related?
It has, at least that I know of, it has at least two steps. One is the review you do yourself. So there's a bunch of scripts, there's a bunch of tooling that you can use. You just download from the internal site and you run the script. So basically, it's just a script, which is kind of like going through the very basic of it. Like, are you checking for certificate validation? Are you using self-signed certificates at all in your, and user-facing service? A bunch of really basic things, right? Mm-hmm. And then there's the real security review that happens, and there's someone from the security team actually doing it. They're also using automated scripts, obviously, but there's somebody from the team using it. We're actually trying to work with them to automate that because nobody has ever automated that at VMware before.
Right.
We have automated the first step, which is easy, I would say. The second step is harder. We have other security-related issues, one of which is how to sign packages. So we have VMware has a key to sign RPMs, but it's stored in a HSM hardware device stored somewhere tucked inside one of the data centers we have. I don't know where it is. I know for sure that it's not available on the public internet. So we're trying to find a way to accommodate that because, again, it's something that we do internally with the build system that VMware uses to build like vSphere and so on, but not with ours. So we're trying to figure out how to integrate with that. We actually did some like Rube Goldberg machine to make it work. It's not ideal, but we're getting there.
Okay. Thank you.
Any more questions? Well, thank you for a very interesting talk.
Thank you.